Hello students, welcome back to the channel. Today we will learn about the Fischer projection and its stereochemistry. We will see how a molecule is assigned R configuration and S configuration. We have seen that if the fourth group is present in top or bottom, either in the top or bottom of an molecule, let's write or if it is present at the top or bottom of the molecule and if it rotates clockwise direction, it is treated as R configuration. It is known as rectus. And if it rotates anti-clockwise, and it is considered as S configuration. Similarly, if the molecule is present in left or right of the molecule, then the order reverses. Then this becomes clockwise, becomes sinister left side, and it is called sinister. Both are derived from Latin word. By here we generally apply the golden rule, and if it rotates anti-clockwise, we consider it R. So by taking this basic method, we will solve the following examples. So I have taken lactic acid for the study of the configuration of this Fischer projection. So let's see. There are certain set of rules which we have to know while solving this compounds. So 1, 2, 3, 4. So we have to first see where the fourth group is assigned. The fourth group is assigned here on the left side. Now, if it is assigned in the left side of the molecule, then we have to see how the arrangement of first, second and third molecule is there. So if we consider if the molecule is 1, 2, 3 and it is rotating anti-clockwise, then it becomes. If we consider this molecule, we can see that the least group, the hydrogen, is located on the left side of the numbering. So we can see it is rotating 1, 2, 3. We will consider 1 the OH group, C double bond OH says 3, the methyl group, and we can see the numbering going 1, 2, 3. It is going clockwise. So according to golden rule, it will become S. We can, as we have already seen, if it is in the least function group is present on either side of the molecule, left or right side of the molecule, then the golden rule will be applied and the original configuration will be totally reversed. So it becomes S configuration. So what we see in rule number 1, an odd number of interchange result in change of configuration. So if we see, if we replace OH from here to here and the carboxylic group to here, so what we see, the complete orientation of the molecule gets changed. We can see that both are interchanged, so it becomes clockwise. First it was anti-clockwise and then it becomes clockwise. Now let us consider the second condition. In the second condition, we can see an even number of interchange result in no change in configuration. Okay, let us consider the even condition. Even condition, what we can see, we can see C double bond OH is in even position and H is in OH position. Let's reverse this, both of these positions. Let's reverse the OH from right side to the left and the H towards the right. Similarly, we will do here upside down, we can see the numbering is changed. Here it goes 1. We have already studied how the numbering is being done. You can watch the previous videos for the reference. Now here for the carboxyl group it becomes 2, and for methyl group it becomes 3, and it becomes 4. So what we see here, first we will consider the the least functional group. We can see the least functional group are present on the left side. So here also it is present, it becomes it is interchanged, so it comes at the right position, right hand side. But if we take the numbering, we can see 1 2 3, it is moving. How it is moving? Anti-clockwise. So if the fourth group is present in the left or right hand side, and if the rotation is anti-clockwise, then it becomes R configuration. Now consider this molecule, it is also rotating in anti-clockwise direction. So we can see 1 2 3. We are just using the fourth group for reference, whether it is upside or down, or it is present on left or right. So we can see the molecule is rotating anti-clockwise, so it is also the same R configuration. Now let's move to the third condition. The third condition states that if 90° or 270° rotation in plane of paper is not allowed due to change in configuration. Okay, now let's see this condition. If I am considering I am rotating it in 90° rotation, so I will be rotating it in clockwise direction. 90° means I will rotate it in 90 degrees, so it will be, the entire molecule will be reversed in clockwise direction. Similarly, if I will be rotating this in 270°, the entire molecule will be reversed in anti-clockwise direction. So we can see the how is the rotation here. 1 2 3, it is going anti-clockwise direction, and it will undergo R configuration. And if we consider here it is R configuration lactic acid molecule, and here let's do the numbering here. The OH will group the first preference, the C double bond OH will get the second preference, the methyl third, and the hydrogen fourth. Here we can see the entire thing is reversed. Yeah, we will see, yes, here we can see the entire configuration is being changed. It is rotating in clockwise direction. The hydrogen molecule, the least function molecule has come into the upside down position. So we know that according to this rule, we see if the fourth functional group is present in upside or downside position, and if it is rotating in which condition, anti-clockwise direction, then it becomes S configuration. So here we can see it is going an anti-clockwise direction, and it is showing S configuration. Now one doubt may arise, why both are in anti-clockwise direction but still it is S configuration, R configuration. So as I have told earlier also, we have to see the fourth group, the least functional group position with respect to the other molecule. If it is upside down, the rules will be reversed in comparison to the left or right molecule. Here we can see it is present in the which position? Fourth position. Similarly, if we will rotate the entire molecule by fixing any one of the molecule in one position, either clockwise or anti-clockwise. Let us consider this. If I rotate, let's do the numbering. 1 2 3 4, this will be 4. And if I fix the carboxylic group, and I will rotate this in either in the let us rotate it in clockwise direction first. So when we rotate this, the CH3 will come here, the OH will go downwards, the H will come here. So what we can see the fourth group comes here, and it becomes 3, it becomes 2, it becomes 1, and here we can see it is present in it is rotating in anti-clockwise. Here it is rotating in anti-clockwise direction, 1 2 3. Here it is rotating like this, and here also it is rotating like this only, 1 2 3. So the configuration of the molecule is not changed. If we have, let us consider if we would have rotated in anti-clockwise direction, then what would have been what would have happened? The fourth group would have been come here, bottom side, and the entire configuration will be reversed, and still it will be remained as our configuration. So if you guys want a quick recap, we have it all here.